Hi again. So in this lesson, we're going to talk about inference for matched pairs, and what that means. So let's look at an example to see. The CAOS exam, Comprehensive Assessment of Outcomes in Statistics. This exam is an online multiple choice test on concepts covered in a typical introductory stats course. Students take one version before the start of the course and another version after the course ends. Before and after scores for a random sample of 10 students are shown in the table and provided in a Google Sheet. So we'll go to that Google Sheet as well. Each exam consists of 40 multiple choice questions, and the score is the percentage correct. Okay, so let's look at what we have in our data table here. We've got student, and the identifier is a letter instead of their name. We have their score before the course, and this is a percentage, right? So the score is the percentage correct out of 40. So we have a before percentage and an after percentage. Okay, so this is an interesting situation where we have the same students and we have a before and after score. So that's what we call matched pairs. Okay, before and after is a really common test to do because that takes into account individual differences, and it's just comparing each person's difference, okay, versus like two independent groups like a control group and a treatment group. Okay, so I want to answer this question right here because I just kind of wrote that, and then we'll see what we're going to do with the data up here. So are these two groups independent? This is a common question we'll ask because there's a completely separate set of tests or test in interval for two independent groups. Okay, so these are not two independent groups. So no, they're not independent because the same students are in each group. Or we could say there's only one group. This is a before and after score for the same students. Okay, so we call that matched pairs. Okay, so this is one example of matched pairs. Okay, so let me show you what we're going to do with our data. We actually are going to subtract, and that's why I have a blank column here, is we want a new column to have just the difference for each student, okay? And then we're going to treat that as a single mean, okay? So let's go to our data. Let's let spreadsheets do this for us. So you should have a matched or a lesson 11 matched pair spreadsheet, and it should prompt you to make a copy since we're going to do some calculations in this spreadsheet here, okay? So I could subtract either way, right? We just want the differences, and the signs are important, but we need to decide which way we're going to subtract, okay? Now I want to make this a, I find it easier if they come out generally positive. It's easier to interpret. So I'm going to do the after. The after would generally be higher than the before, right? So I'm actually going to do the after minus before. And to do that with a formula, I'm going to start with equals, then I'm going to click on C3 minus B3. Okay, so I can click on the cells, or I could also type C3 minus B3. And when I hit enter, the spreadsheet is smart enough to think that I probably want to do that for that whole section of this table, and I do, so I'm going to hit check or tab. And then voila, we have all of our differences, okay? Looks like they are all positive. Just double checking. Yeah, okay, great. Some bigger, some smaller, but no one actually went down, so that's kind of a nice thing. But you could, in these differences, you could have a mixture of positives and negatives, totally fine. Okay, so this gives us the data that we're going to use in Snaplet, okay? Now, let me go back to the notes and write down what we just did. Okay, so in our spreadsheet, we have the spreadsheet labels A, B, C, in case you're not haven't used spreadsheets a lot. And then our rows are 1, 2, 3, 4, or actually, I think I had a blank row, so actually this was the 3. Fix that real quick. Okay. 2, 3. Okay, I just want to write the formula, and this would be column D. So we did, in D3, we did equals C3 minus B3, okay? And then my spreadsheet kind of did an autofill for me, but sometimes you might see a little square or dot on the lower right corner. You can also click that and drag it down, and it'll autofill. It's a copy down feature, and what that will do is it will change it from C3 minus B3 to C4 minus B4, and it'll copy all the way down just like that. Okay, now just a note, we're going to use the after minus before. To keep the differences positive. Okay, but you could do it either way. So if we did B3 minus C3, that would also work. It would just change the interpretation. It would change the signs on some things, so it'd be good to play around with that. Would change the signs and interpretation. Okay, so when you're doing in a stats class, when you're doing homework, take a look and see if they tell you which way to subtract, because then you'll be sure to keep it the answers the same that are programmed in, or if it doesn't specify, then it might accept either way. Okay, so we're going to copy that data from the spreadsheet into Staplet. So then we're going to copy the differences. You see that? Into Staplet, okay? Okay, so before we do that, let's go ahead and write out our hypotheses here. Okay, so let's do a hypothesis test. At the 5% significance level, does it appear there is a significant difference between the before and after scores? Okay, so they might want to, ask us, are the after scores significantly higher, but they're actually just doing significantly different. So we will do a two-tail test here. The null will be mu. So we're going to treat this, because now we have a single list of numbers, right? We're going to treat this as a single mean. But some books will put a D or the word difference or something in there to indicate that these are not just, it's not just like a one variable thing, it's a difference of two things. So I'm going to write mu diff. So we'll put diff on there, but we're going to treat it the same. And so if there was no difference, that would be a 0% difference, right? And these are all in percentages, so I'm going to write my percent in here. And our claim will be that there is a significant difference, so mu diff different, that's a couple differences, mu diff different from 0%, okay? And we have our alpha equals 0.05. Okay, so we have already found the differences in our Google Sheet. Now we're going to go ahead and put that in to Staplet, and then we'll get our summary statistics, okay? Also, we can check, I think on the next page, we're going to check the conditions and make sure we can do this. Okay, so let me put this into Staplet. So I'm copying just the differences, and then the same steplet we were using before, one quantitative variable single group. So you can think of it as it is a single group of students, right? We just have differences for those. Oh, whoops. Got to put it in the data. And what do I want to put? I want to put difference. I want to remind myself of CAOS scores. I'll put after minus before. That way I can remember which way I did it. I don't want two minus signs. There we go. Begin analysis. Okay, great. So for the moment, I'm going to go to the summary statistics, and we're going to look at both hypothesis testing and confidence intervals for this situation. So let's write down our summary statistics. It says write the observed statistic / point estimate. Okay, so that is our sample mean, and it turns out to be a whole number, which is unusual, but it's actually 14%, right? Okay, so let me write that down first. Our x bar equals 14%. Also important to keep in mind when you're dealing with percents, we need to just remember that the data, how the data are formatted, right? So the data are sort of whole number percent, so not, for example, 42.5%, it's written as 42.5, not 0.425, right? So these are already percents, so when I interpret my x bar, I know the number 14 is actually 14%. Okay, so that is our point estimate, and let's go ahead, since I'm here, I'm just going to write down my S, because I think we're going to need that at some point. Our standard deviation is 6.3683, and our N is 10. Okay. So just writing those things down because I'm sure they're going to come in handy. Let's go to the next page and see what we're going to do next. Okay, so we're actually going to do a simulation first, and then we'll go to the theoretical. So let's do the simulated test and confidence interval. Kind of nice because conditions don't need to be met, right? So we can just do our simulation. We just put our data in Staplet. We're ready to go. So we are already in there. We're going to scroll down to perform inference. And then which simulation to use? Okay, so let's look at that. Simulate, so it says, use simulate mean difference for a hypothesis test. So we can do a simulation for a difference in Staplet. And then that's for a hypothesis test. For a confidence interval, we're going to simulate the sample mean, okay? And it's always important to remember where things should be centered, right? So you can double check that you're using the right one. Okay, so when we are doing the mean difference, our difference here is 0. That's our null, so that should be centered at 0. When you're doing a sample mean, then it should be centered at that sample average. Okay, so let's go over and do that. Okay, I'll come back to the conditions in nearly normal. So simulate mean difference. Let's just review this and double check that this is what we want. It says applet assumes data values are differences from paired data. Okay, matched pairs or paired data. This procedure simulates the distribution of the mean differences when randomly shuffling the outcomes within each pair and calculating the difference for each pair. Okay, so remember we're simulating the null distribution, which is no difference. So that means for each pair, maybe that difference is just due to random chance, right? So it could equally be swapped if there really is no difference. So that's what it's doing, is it's randomly shuffling, but not every single one every time. It's going to do a random, like a kind of flip a coin for each one on whether it should be flipped or not. I think that's how that works. So let's see what it looks like. Let's do 1 first and see. Simulate mean difference. Okay, so it doesn't show quite as much as it does with on stat key, so I'm not sure that's super useful. Let's do the 2000. Okay, so here's 0. This is no difference, so it's centered at 0, and then we're going up, and you can see the differences here in each sample, each simulation. So what we want to do is find out how likely it was to get the difference we got, right? So there's always 2 of these things, but we're usually just going to use one or the other, right? So count the number and percent of dots, so that's a p-value, right? And then, excuse me, endpoints is a confidence interval. But we wouldn't use the confidence interval with the 0 in the middle. So yeah, so usually you're just going to use one or the other of these with a different simulation. Okay, to find our p-value, we've got to see, well, how likely is it to get this difference of 14 if there's really no difference? So we're going to count the number percent of dots greater than or equal to 14. Okay, we got 1 dot out of 2001. And remember, we're doing a two-tail test, so we're going to multiply this by 2. So we got 0.05%, so very small, 0.0005, right? Okay, so let's write this down. Okay, so back to the notes here for a second. Perform inference. Okay, so simulate mean difference. So this is for the hypothesis test. Simulate mean difference. Add our 2000. For the hypothesis test, we want to know how likely it is to get a difference as large as ours or more. So we got our simulated p-value. Two times, and it was 0.0005. Okay, so in Staplet, they always give it to you in percent, so we need to move the decimal over 2 places. 0.0005, so 3 zeros, yes. Okay, equals, I got my calculator here, I think it's just going to be a 1 in the 3rd place. Let's just double check that. Yeah, 0.001. Okay, and remember this is a simulation, so this will vary. Okay. So we would let's just write down our decision. We would reject the null, right? Okay, we'll summarize this after we play with all the stuff. Okay, so now for the confidence interval, okay, so that was, this screenshot down here is the mean difference. And so always pay attention to where it's centered. Centered at 0, okay? I don't think I did a screenshot for the other one. So let's go ahead and do the other one. For the confidence interval, we're going to select simulate sample mean. Looks like I got a typo there. I wrote simulation. So I'll fix that. So we're going to go back up to the top, simulate sample mean. Okay. This one says it simulates the distribution of the sample mean when selecting samples of the original size with replacement from the original sample. Okay, so this is taking just that list of differences, like it's in a bucket, and it's sampling one at a time, right? And it's doing 10 with replacement to get one sample, then another 10 with replacement to get another sample, and it's doing that 2,000 times. Okay, so that gives us a good estimate of the standard error. And this time we want the endpoints. We got to figure out what our confidence level is, though. I didn't enter the confidence level. Okay, so let's go back and figure that out. I didn't prompt us to do that. So our confidence level, got to remember what we're doing here. We have a two-tail test with alpha equal 0.05. Okay, so that means both tails add up to 0.05. I'm going to do a, I'm going to use this space for a picture, and then, so essentially this, since both tails add up to 0.05, I'm going to write 0.25, so that's half and half, right? So this would be 1 minus 0.05 in the middle, which is 0.95. Okay, so we need to do a 95% confidence level, and then let's do that, and then we'll write the conclusion down here. Okay, so find endpoints for the middle, 95%, find endpoints. Okay, so it's saying the true average difference would be between 10.5% to 17.75%. So let me write that down. 10.5% to 17.75%. Okay. So now, and I just wrote that down right here. And because it's percent, I'm just putting it after each one. It's easy enough. I could also just put it at the end. Okay, now let's summarize both of these together. Since we're getting more practiced at this, we're gonna do a test, an interval for every single thing just about, and then we can summarize those together, okay? So with a p-value of, we got 0.0005. I switch colors. The p-value of 0.0005. Oh, sorry. I was looking at the one before I multiplied. 0.001. Glad I caught that. The p-value of 0.001, we reject the null. And we could say that's pretty strong evidence. There is strong evidence of a significant difference in the true average. We're using the word difference twice, right? Significant difference in the true average difference. The true average difference of before and after scores. Okay. Now, if we also just did a one-tail test, we could have said there's a significant improvement, but this one was framed as a two-tail test. Okay, but then also that's what the confidence interval helps us with, right? With 95% confidence, we can say that on average, the after scores are 10.5% to 17.75% higher than the before. scores. Okay, I want to get that word average in there. So there's a few different ways you could word that. So make sure you have on average, or you could frame it in the average difference is between blah, blah, blah. Okay, great. So let's continue this example, but we'll do it for the theoretical method in the next video. So I'll see you there.